Hello students, welcome to Sri Jayendra's Rank Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 4 of the Units and Measurement. Let's begin. So, in the previous classes, we have discussed about the dimensions. We have discussed about the applications of dimensions. One more principle that we used is the principle of homogeneity. And today let's begin with the some new topic, that is dimensionless quantities. Now, what do we mean by this dimensionless, and which are the quantities which are not having a dimensions? So first, what is the dimensionless quantity? We can say a quantity which does not possesses, does not contain any dimensions, or the dimensions can be written as m0, l0, t0. These are the dimensionless quantities. Which are they? Which are they? One category would be a quantity which is having ratio of similar quantities, such as, think, you heard about the refractive index? Did you? Denoted as an n. It is a ratio of c is to v. What is c? Speed of a light in air or vacuum. What is v? Speed of a light in medium. So again, this is speed, when this is speed, so this two would cancel each other, and so that refractive index having a no dimensions. This is m0, l0, t0. Got it? Which quantities other than the refractive index are considered as in dimensionless quantities? Do you know? The relative density. We say it's a density of an object. Divide by density of water at 4 degrees Celsius. You will learn this in next units. But today, at this point of time, we are interested that this is density. Again, this is density. Density by density. It would cut it down. And so the relative density does not have any dimensions. One more, strain. Three kinds of strain would be there. But here we are considering, or here we are interested in a normal form of a strain. It's a change in dimension. Change in dimension. Divide by original dimensions. So even strains are dimensionless. Three kind of strains could be there. One is the longitudinal strain. Another is the lateral strain. One more, it's a volumetric strain. You will learn this, but do remember one thing: strain is a dimensionless. So there are many others too. In the next units, you will learn about this all. But one thing for sure, that when any physical quantity is there, which is just a ratio of two similar quantities, then this will represent a dimensionless quantity, a quantity which does not have any dimensions. Okay. Other than this, there are two supplementary quantities are there. Have you remember two supplementary quantities? Which are they? Two supplementary quantities. Which are they? One is the Think it's in plane angle, yes. And second, it's in solid angle. So this two, plane angle and solid angle, both these quantities are unique one. Why I said unique one? Because these two are having units, but not the dimensions. These are the exceptionals. Otherwise, otherwise, a quantity does not have a unit, does not have a dimensions. But these two are having an units. Remember unit of plane angle, what it would be? It would be in radian. Unit of solid angle, it's in t radian. But this people does not contain any dimensions. So they are m0, l0, t0. These two are the second category of the dimensionless quantities. Second. And last but not the least, this all trigonometric ratios, all trigonometric ratio are dimensionless. This is sine, bracket of sine is a dimensionless as well as sine itself completely dimensionless. Cos, tan, sec, cot, cosec. This all are dimensionless. All trigonometric ratios are dimensionless. Next, log, logarithmic. This bracket is having a dimensionless value. Next, exponential function. Exponential function, that is e to the power something. This is dimensionless. So all this represents dimensionless quantities. So let me revise you. First, all those quantities which are ratio of same quantities, let's say refractive index, let's say relative density, let's say volumetric strain, let's say lateral strain. Second category would be the angles and plane angles and solid angles. These two are the dimensionless. But angles, I mean plane angle and solid angle, are having units, but but they are not having a dimension. So it is there's specific approach. Next, all trigonometric ratios are dimensionless. You can say sine, cos, tan, sec, cot, cosec. All these are the dimensionless. Logarithmic function, whatever we have written in the bracket of the log, whatever, it is considered as a dimensionless. It does not possesses any dimensions. Next, exponential function, whatever written over this bracket, it's an e to the power something. This is dimensionless. Okay, so we understand what are the dimensionless quantities and which are they. Now let's mix this concept with principle of homogeneity. Let's work on it. Let's say we have been given y is equals to a sine omega into t. Here a represents amplitude which should be measured in somehow distance. So it's a unit of distance. T represents time. So that should be measured in second, that you know. But you do know dimensions, dimensions of y and omega. You need to find out this. So dimensions of y is required, dimensions of omega is required. What should I do? And how could I find it out? So let's start with this omega into t. Let's start with this omega into t. I know that omega sine and its bracket are dimensionless. sine and its bracket is dimensionless. So I can write like this: omega into t is equals to 1. Why I have written 1 here? It would be easy to calculate. So I need a just dimensionless quantity. Dimensionless quantity could be anything, any number. You can write any number, but for calculation, it would be easier if I consider as an 1. So I have written omega into t is equals to 1. What I need the dimensions of omega. So omega should be is equals to 1 by t. Now time, 1 t represents second. So omega represents 1 by second, or I should say it's in second inverse. So dimensions of omega, it is m0, l0, t to the power minus 1. This is the dimensions of omega. Now half of the battle has been won. Represents. Now I need a y. I know that this sine omega t, it is a dimensionless as it is a property of an trigonometric ratios, that all trigonometric ratios will be dimensionless. So I simply write y is equals to a. What is a? It is amplitude in which it is measured. It is in category of distance. So even y would be a somehow meter. So this is dimensionally it is m0 l1 t0. Is it clear? Yes. Will you be able to solve next question? Let's look next. Let us suppose I have been given that y is equals to y is equals to 1 minus e to the power alpha t square. Y is equals to 1 minus e to the power alpha t square. I have been given that t represents time. T represents time. And I need to find out the dimensions of alpha. What will alpha represents? So what I know is that alpha into t square, it is a power of an x e. So alpha into t square, this should be a dimensionless, or when dimensionless would be there, I can write it equals to 1. So I can write like this: alpha into t square equals to 1. So I can write alpha should be equals to 1 by t square. T is the time, so this is 1 by second square. And now things have been done. Alpha will represent second inverse. So I can write dimensions of alpha as m0, l0, t to the power minus 2. Got it? Yes, well done. Let's move to the next question very quickly. Next question. Let's say they have been given y should be is equals to a cos omega t minus of kx. Y is equals to a cos omega t minus kx. And they have given this. T is the time, k you don't know, x is the position that can be calculated in meter, omega you don't know. Again, a is a distance. Technically, it is an amplitude. And y you don't know. So your requirement would be to find out the dimensions of k, to find out the dimensions of omega, and to find out the dimensions of y. So k, omega, and y. This is what I require. How should we do it? What should be done? Look at this. This is trigonometric ratios. Trigonometric ratios are dimensionless. So y should be equals to a. So y should be a meter. Yes. So this is L1. It would be an y. Things has been done. Next, look at this. Omega t and kx. This two are associated with a subtraction sign. Can you say this? Yes. If they are connected with a sign of a subtraction, what can we conclude? Think, I can give you a hint. Do you know principle of homogeneity? Now think yourself. Yes, some of you might know this. When and when two quantities are associated with addition or subtraction, they must be of same dimensions. So I can write like this: omega into t can be equals to 1, as well as k into x can be equals to 1. Now I need the dimensions of omega, so that is 1 by t, and I need the dimensions of k as well, it is 1 by x. So this is second inverse and this is meter inverse. So I can write like this: this is m0, l0, t to the power minus 1. This is m0, l minus 1, and t to the power 0. Got it? Yes. Able to solve the next question? Let's have a look. Next question is y is equals to b into log of alpha into t square minus beta into x square. You need to find out dimensional formula of alpha into beta. That is all we require. Where this has been given, t is the time, x is the distance. Now look at this. Again, same principle. Certain terms has been written in the log, whatever that has been written within the log, whatever that has been written within the log. A is a dimensionless, so I can write like this: alpha into t square equals to 1 is equals to beta into x square. Yes, so I can write like this: alpha should be is equals to 1 by t square. And if I compare beta into x square equals to 1, I can write like this: beta should be is equals to 1 by x square. What I required alpha into beta. So alpha into beta is equals to 1 by t square multiplied by 1 by x square. So this is m0, l minus 2, t minus 2. Yes, can you do this? Great. Yes. Let, let's move to the next and last question. This question is having something like this. F is equals to y into e to the power alpha minus beta t square, where F is the force, F is the force, T is the time. You require a dimensions of y, as well as you require a dimensions of alpha by beta. So what can I do? On a very first note, I know that this term is dimensionless. So dimensions of F and dimensions of y is equal. So y is having a dimension of same as that of the force. Now, dimensions of force. What is this? It's an kg meter per second square. So I can write like this. It's an m1 l1 t minus 2. This is kg meter per second square. Now, next, alpha and beta t square. Both are associated with a subtraction. They can be associated with subtraction at that point of time only when this two having same dimensions. So I can write like this: alpha must be equal to the beta t square according to the dimensions. So I can write like this: alpha by beta should be equals to t square. So dimensions of alpha by beta, it is m0, l0, t2. Got it? Yes, very good. So now I think you would be able to do the questions on this all principles. So now let's move to the physical quantities having same dimensional formula. In many examinations, certain questions have been there which ask that choose the choose from the following quantities which are having in same dimensions. Even a reverse kind of question could be asked. They ask that choose from the following which are having a different dimensions. So it is a very bigger list. If you just look at this, it is a very longer amount of lists, and even this list could be expanded. But here I have mentioned certain qualities which have been generally asked in previous year questions. So you just go through this. Do not try to remember it. Do not try to remember it. Just go through it once, twice, or thrice in a day, and by slowly you will remember this. Yes. So just look at this. There are certain quantities. What we can discuss is that we know that distance, displacement, radius, light year, wavelength, and radius of gyration. All these are the dimensions of length. Same way, speed, velocity, velocity of light. All these are having in dimensions of velocity only. It's an L1 T minus 1. Same way, force, weight, tension, thrust, all are having in dimensions of force only. It's in kg meter per second square unit. Impulse, I hope you remember this. F into T is equals to mv minus mu. So this F into T is said as an impulse. This is impulse. And this is, this is change in momentum. So impulse and change in momentum are having the same dimensions. Next, work, energy, moment of force. Do you know what does it mean, moment of force? When word moment comes, this represents distance, or rather I should say it should be multiplied with the distance. So moment of force, it is a force multiplied by distance, which we call as a torque. Force multiplied by distance, which we call as a torque. All this are having the same dimensions. Next is the angular momentum, Planck's constant, angular impulse. All these are having the same dimensions. Do you know what is Planck's constant? Do you know? Let's look at this. E is equals to hf, where E is the energy, F is the frequency, and H is the Planck's constant. So now you can remember easily. Stress, pressure, modulus of elasticity, all these are having the same dimensions. As well as we have already discussed about the velocity gradient. What is gradient? So when as we discussed previously in second or third lecture, that when gradient would be there, when word gradient would be there, it is divide by distance. That is what we call as a gradient. Decay constant, rate of disintegration, this all represents time inverse. It's in second inverse what we can consider. So you just go through this. There are some others too. There are some others too. That are the this all pairs are having the same dimensions. So just go through it once or twice, and you might get an idea that how could I find it out. Now let's discuss, that is, the limitations of dimensional analysis. That what are the limitations, what problem we could face, when we are using the dimensional analysis. First is, dimensionless quantities cannot be determined, as we discussed. When we use kinetic energy is equals to half mv square, we can find it out mv square, but we could not do anything with the half. So for 1 by 2, we need to do multiple experiments, and from there we can find out this data experimentally, but we cannot find out a 1 by 2 using the method of dimensional analysis. So this is probably its biggest challenge when we are using the dimensional analysis. Next, constant of proportionality cannot be determined. It will be the same thing. Next, this method is not applicable to derive trigonometric functions or logarithmic function or exponential functions. Why? Because all these are the dimensionless. All these are dimensionless. So even they are there. Let's say y is equals to a sine omega t. It is a relation which is valid according to the physics. Now, as I know, sine omega t itself isn't dimensionless. So only the dimensions can check whether y is equals to a or not. And it would be. So dimensional analysis cannot help regarding this. So these are the certain limitations. These are the certain limitations of the dimensional analysis method. Yes, but applications of dimensional analysis are very much powerful, that we are using it in very much applications that makes our task very easy in JEE mains. Even in the paper of this year, certain questions have been asked that can be solved very easily using the applications of dimensional analysis. In this year, even Neet has asked two questions which can be solved directly with the help of dimensional analysis applications. So study this very carefully. Go through this class notes very carefully. Yes? Okay. Let's check it out, certain MCQs. Let's taste it. Whether we have studied up to a good level or not. Let's look at this very quick. First, a unitless quantity. Think always a number, maybe a physical quantity without dimensions, has no dimensions, and all the above are correct. A unitless quantity, what would be the correct answer? What would be the correct answer? A unitless quantity, would it be a number? Could it be a number? Yes, it could be a number. Let's say we have been given n equals to 3, and this 3 does not have any unit. It's a number, yes, could be. Maybe a physical quantity. It is maybe a physical quantity without dimensions. Yes, look at this. This 3 does not have any dimensions. Yes, has no dimensions. So as all three are correct, correct answer would be all of the above are correct. Can you solve it? Very good. Let's move to the next. Which of the following is not dimensionless quantity? Which of the following is not dimensionless quantity? Now, think for a while and tell me, does angle having a dimensions? No, angle does not have a dimensions. Okay, one more question from my side. Do an angle having a unit? Yes, angle is having a unit, that is radian. But dimensions, it's an m0, l0, t0. Yes. Strain, again, it is having an m0, l0, t0 dimensions. That means no, it's a dimensionless quantity. Specific gravity, what is it? Specific gravity, what is it? It is the relative density. is the relative density. Again, it is having in dimensions of m0, l0, t0. And density, it's in mass divided by volume. Density is mass by volume. What is mass? It's in kg. Volume, meter cube. So this is m0, l1, t minus 3. Now go through the question again. Which of the following is not dimensionless quantity? So density is not a dimensionless quantity. It is having a dimensions. Yes, let's move on. If the dimensional formula for the physical quantity is m1 l2 t minus 2, then the physical quantity is m1 l2 t minus 2. So what you need to do is you need to find out the dimensions of every quantity. I can help you for two quantities. Let's say which one should I use? Okay, shall I take torque? Let's move on. So torque is having the force multiplied by distance. Force is kg meter per second square multiplied by distance m. So this is kg meter square per second square. Yes, it is the correct answer, m1 l2 t minus 2. So this is just a coincidence that I have chosen a first quantity and it would be a correct answer. This would not be the case every time. This could not be the case for every time. So what you need to do is you need to go through this all options by trial error method, and whichever would be the correct option you can take it. Yes, let's move to the next question. Yes, the product of energy and moment of inertia has the same dimensions as. Now first, energy, it's in kg meter square per second square. Yes, multiplied by moment of inertia. What is the unit of moment of inertia? It's an kg moment of inertia, which we said as an mi. It's an kg multiplied by distance square. It's an mr square, or we can say mx square. X is the distance, m is the mass. So when I multiply this is kg square meter to the power 4 divided by second square. So look at that. Go through the trial error. Which option should I choose? Square of the linear momentum. What is linear momentum? I should say P is equals to m into V. So this is kg meter per second. If I kg meter per second, sorry. If I make a square of this, it would be a kg square meter square second square. So no, this could not be the option. Now square of the angular momentum L, it is mvr. So this is kg, this is meter per second multiplied by meter. So this is kg meter square divided by second square. And I need to perform square of this. So if I take L square, it's an kg square meter to the power 4 second to the power. Yes, it is correct option. So again, this is a heat and try method. You need to do it. There is no other alternative. Yes. So let's move to the next question. Yes, dimensional analysis method can be used. Do it yourself. To check the correctness of the given equation, to convert one system of unit into another system, to derive the equations, and all of the above. Which one is correct? Think, think for a while. Yes, we have used all this to check the correctness, to convert one system to another, to derive the equations. So all these are correct. This should be the answer. Next question. The quantities which are added or subtracted, yes, or equated in a physical equation should have the same dimensions. What is it? This is principle of homogeneity. Yes. So this is all about dimensional analysis. From where we have begun in the dimensional analysis, what we have done is we in a very first lecture of dimensional analysis we have learned how to prepare or how to manage the dimensions of different quantities. Then we have started its applications. In the applications, we have go through this three applications first to convert from one system to another, to check the correctness of the physical equations, and next to derive the relations among different quantities. Then we have gone through the principle of homogeneity, then dimensionless quantities, and then this sort of questions. I hope these things are clear. Practice it very carefully. This will help us directly, indirectly throughout the syllabus of 11th and 12th. These are the bases, and we are going to use dimensional analysis in a very frequent manner at in every approximately every unit. So, thank you so much. Thank you for connecting to me. Thank you. Go through this very carefully, study this very carefully, practice approximately 70 to 80 questions based on the dimensional analysis. It will give you a command over this, and this will help you to crack your examinations. Thank you. Have a good day. Take care. Bye bye.